Hello, welcome to this uh, data analysis tutorial. Today I'll be dealing with a t-test. T-test is one of the tests we use as a test for comparison of means. For example, if you want to know the difference between two variables, for example, you've done an experiment. I want to know if you've done an experiment on on girls and on boys, and you want to know if the experiment has actually achieved the result. You can use t-test to compare the two groups. So there are different types of t-test. T-test was introduced by a man named William Seeley, and I think it started when he was a student. So sometimes they call it student t-test. It was the name they gave him. He was like a T. They called him T. So the name of the test became student t-test. So t-tests are statistical tests used to determine if there's a significant difference between the means of two groups or between a group mean and a known population mean. Just forget about this. I want to explain the different types of t-test, then you understand what it means. So there are different types of t-tests. The first one is one sample t-test, the second one is independent sample t-test, and then the third one is paired sample t-test. So I'll go straight and talk about one sample t-test. Is the best way to understand this thing is to see it being done. One sample t-test compares the mean of a single sample to a known population mean. So let me just give a test. Let me just do it so that you see it. So I open SPSS. Already have a data I prepared. So this is the score of about 30 students. You can see there are 30 of them. So now in one sample t-test, you have a assumed, like you have a mean, a cutoff mark that you already set. For example, in this particular example, the teacher already predicted that the students will score, the average score will be 40. So now you want to run a t-test to see if there's a statistical significant difference between the actual score that the students have and his assumed score before they even gave the test. So he had assumed that okay, the average score is going to be 40%. But now I want to see if now after he has given the exam, you can see many of them have different scores, but you want to know if what he predicted is different from the actual score of the student. So we'll go to analyze, you go compare means, you see one sample t-test. So you pick it. So well, you just have one variable, you pick it. Then the test value. Now remember I said he assumed 40%. He assumed that okay, the average will be 40. So I'll put the 40 here. That's all basically. In the options there's nothing much to put there. Just click continue. So I'll go and I'll click OK. Let me open this. So you can see now that now the this first box so it shows me there are 30 students. Now the mean now of their scores is 58.13, then with the standard deviation, standard error. So now remember the test value is 40. So the t value now is 4.232, and then the significance value, I want to use your point to explain, is 0.000, which means there's a significant difference between the score, the mean, the predicted value, which is 40, and the the actual average of the students, which is 58.13. So the significant value is 0.00, which is also the p-value. So I want to explain what we mean by p-value. So how we made that decision is we use what we call p-value. P-value is what we use to decide if something is significant or not. If it's less than 0.005, you say it is significant, there's a significant difference. Like in this case now, 0.000 is less than 0.005. So we say there's a significant difference between the predicted value, predicted average score from the actual average score. Therefore, we accept that there's a difference. So we are using this significant value is also the p-value. So that's that for the one sample t-test. We'll be able to prove that the predicted value, which is 40, is significantly different from the actual value, which is 58.13. So we'll go over to the next type of t-test, which is the independent sample t-test. The second one is independent sample t-test. Now, it compares the mean of two independent groups. I want you to notice the word two independent groups. For example, males and female are independent groups. So we want to compare the scores of, so a teacher had given a test in a class, and in that class there are two independent groups, males and females. Now, I want to know if there is a significant difference between the scores of the males and the females. So I'll run an independent sample because I have the scores of the males is independent from the scores of the female. So I want to find out between these two different groups. I want to find out, I want to compare their scores. So you can see I have 50 students, males and females with their different scores. I want to do that analysis. So I'll go to analyze, still go to compare means, then I'll go to independent sample t-test. Then I will bring in my score here, and then I'll bring gender here because gender is a grouping variable. Gender is a grouping variable. So I'll define the groups. Group one, I will just put one there, then group two, I'll put two. Let's see how it goes. Yeah, I've defined the groups. So I'll just go ahead and click on OK. Let me see. Okay, there's a problem with the way I did that. Let me go and do it again. I think there's a problem with the grouping variables. So they want me to tell them which one is the male and which one is the female. So in the grouping, I want to take this one out, bring it back. So define variable, this is, I'll just call this one males, male. Then group two, I'll call them female, female. So I'll go, okay, if it doesn't work, I'll have to do some basic changes. It still didn't work. So now it didn't work because we did not code our so let me just go ahead and apply a code to this thing. So I'll go to values. Now notice what I'm going to do. I'll say value one. I apply one to male. I'm going to add it. I'll add it, then two female. So I just want to put numbers there so that it'll be easy for me to. So I'll come back here. Wherever I see male, I just go and put one. Anywhere I see males, I'll put one there. In fact, I can just go ahead and oh no. So anywhere I see male there, I'm just going to put one. And anywhere I see female, I'm going to put two because I've already coded it behind that two is I'm going to go ahead and click on independent sample t-test. So let me just reset this one. Let me reset this. So I'll bring in score here. I'll bring in gender, then defining the groups, I'll put one. Here I'll put two, then continue. Then I'll go OK. You can see the test has showed up. So you can see that the number of males, this is group statistics, is 15. Number of females is 35. The mean score of males is 56, while the mean score of female is 53. So I want you to take note of that. The difference is not even much. But let's see if the difference between the scores of the males and the female is significant. Now the significant value is this point. Look at it here. Is 0.483, which is greater than 0.005. Therefore, we will say that they will reject the hypothesis. We will say that there is no significant difference between the scores of the males and the females. It's just simple. You understand? So that's just it. That's just paired sample t-test there. We've been able to use it to prove that males and females do not have relatively the same score. So the next one is so this independent sample t-test. So the next one is paired sample t-test. Now in paired sample t-test, you want to compare something that happened, like you want to compare a before and a after. For example, if you have if you are rearing broilers like poultry, and then you want to introduce a certain type of feed, you take their measurement before you start giving them the feed, then you take their measurement after like 3 months of giving them that feed. You want to know the effect of that feed that you gave. That feed is called a treatment. You want to know the effect of of that feed. So you compare the weight before and the weight after, and that can give. So you can use t-test to do that. In research, for example, when you want to give BP drug to like 100 people, you take their blood pressure and then you give them the drug for like 3 months. Then after 3 months, you take their blood pressure again. You compare their blood pressure before and their blood pressure after. So by the time you do that comparison, you know whether the new blood pressure lowering drug is effective or not. So that's paired sample t-test. You can just go ahead and read this, but I've just explained what it is. So let me go ahead and just run a paired sample t-test. So you see weight before and weight after. I want to know while 50 broilers that have been measured before and after introduction of a feed. So I want to know if that feed is is effective. So I'll go to paired sample t-test. So in paired sample t-test, I'll just click on this and impute it and click on OK. So I'll go to my output window. So the mean weight before is 25.1, then the mean weight after is 54.84. So there's total number of 50 and 50 and birds were measured before and 50 were measured after. So let's just forget about the correlation. We'll do correlation in another day. But this is important place. You see that the t-test is minus 9.819. That's good, but the most important thing is this significant value, which is also your p-value. It says it's 0.000, which is far lower than 0.005. Therefore, we'll see that there's a significant difference between the weight before and the weight after. So that's that for. So you see how you've been able to use t-test to measure between two groups. Please, I advise you to watch this video again. It's very important. You watch it again and do some other research to really understand the use of t-test, and there are also assumptions behind t-test. Thank you so much.